Hi Year 10s, this is your solutions video for the Mathspace from week 1 of term 2. You can find this page here in our OneNote under Learning from Home Mathspace Solutions week 1 trig. So these are the most commonly incorrect questions. Now this question came up even at my old school, even though I know you guys are doing these correctly from the textbook. Let's talk about why this is happening. Maybe it's just unfamiliar. Find the value of f correct to 2 decimal places. So f is a side length in our triangle. We figure it's a right angle triangle, so we can use some of our trigonometric ratios. Let's see what we've got. We've got an angle, the side next to it, which is the adjacent side, and the hypotenuse, the one opposite our right angle. So we are using cos. So we set up our formula. Cos of theta is adjacent over hypotenuse, and we fill in what we know. Cos of 41 is f over 15. And then we simply want to find what f is. We see that it's being divided by 15. So to undo that, we're going to multiply by 15 on both sides. Calculators out. 15 times cos 41 is 11.32, and there's more to it, but it says correct 2 decimal places, so I'm stopping there because the next digit is a 0. So I'm not going to put that there. So that is equal to f. So there it is. Next one, this is Hermione's house. It has outer dimensions as shown. Find the height of the house. That's going to be this long line here, rounded to 1 decimal place. So I'm seeing that the height is made up of this part here, which we can tell from this side, the side length, that bit there is 3.5. And then you've also got this bit up the top here, which you are not told straight up, but which is part of a right angle triangle that you have here. Well, there's 2 triangles. You can choose which one. It does not make a difference. Let's call this leftover bit here x. If we use this right angle triangle, let's see what we know. We've got this side is 4.9, and then this bit here, we're not told it directly, but we know, look, the house looks symmetrical, okay? 3.5, 3.5, 4.9, 4.9, it's on the same slope. So this is half of the 9.2. So this bit here is going to be 4.6 meters. Let's just redraw our triangle because that diagram's getting a little bit cluttered. There's your 4.9 and here's your 4.6. So you'll notice that we don't have angles here. What we have is a right angled triangle. We know 2 side lengths and we want to know one of the other side lengths. So that is a Pythagoras question. We write Pythagoras' theorem. C squared is a squared plus b squared. It's always a good idea to label your diagram with what the sides are as well. So our C, our hypotenuse, is this one, and then either of these can be A or B. All right, let's fill in what we know. We said that C is 4.9, so C squared is 4.9 squared. A squared, we've said that this side can be A, so it's going to be x squared plus 4.6 squared, because that was our B. Now, at this point, you can subtract 4.6 squared from both sides to leave x squared there, or you can put these in your calculator now. I'm going to subtract 4.6 squared from both sides. So this side is going to be 4.9 squared minus 4.6 squared is x squared. I'm just showing you a way where you can get to the final answer by putting all of it in your calculator. So we wanted x. X is the square root of x squared. We're going to square root both sides, the whole thing. So what you're putting in your calculator to find x is, this is what you would type, square root bracket 4.9 squared minus 4.6 squared, close bracket, and that will make your square root do all of that. You can do it bit by bit, whatever you prefer. I'm going to put my brackets in, 4.9 squared minus 4.6 squared, close bracket, and I'm getting 1.6881, etc., etc. So I look back at the question, as you always should, and see how many decimal places did they actually want? Just one. So 1.68 whatever, that rounds to 1.7. All right, let's just check. Does that sound reasonable? Obviously, that's not the whole height, because I was a little bit worried for a second there. That's not the whole height. That's just this little bit up the top here, right? So the height is made up of, we said that 3.5 plus our 1.7. So that is 4.5, 5.2 meters. Yeah. All right. I did ask you before if 1.7 sounded reasonable. I looked at the diagram and it really doesn't look reasonable, right? If this looks about the same length as that, and it's clearly, if that's 1.7 and that's 4.7, it clearly doesn't work. But remember that diagrams are generally not to scale at all, not at all to scale. And in fact, if we look at this line here, which is supposed to be 4.9, that's supposed to be really quite close to this length, and you can see it's actually much longer. So for this to actually be 4.9, that actually has to be a lot shorter. So it would really, to scale, look more like this, and that would be a much shorter length there for x. It's like 1.7. And there's our final answer for that. Okie dokie. These last few are very similar to each other. These are all finding the angle when you're given the ratio. And I think you guys are doing these kinds of ones fine in your textbook if you're given a triangle and you have to make this equation, but that being given this, it just looks very foreign. So I'm going to give you a triangle that you would have got this from. So tan of t, so let's call an angle t. Tan of t is 9 over 10. So tan of anything is the opposite over the adjacent. So that means the opposite side is 9 and the adjacent side is 10. So if you'd been given this triangle and asked to find t, I think you would have done this. Tan of theta is opposite over a. So tan of t is 9 over 10. Then you would have remembered to do your tan inverse. So t is tan inverse of 9 over 10. And you would have figured out that that is 9 over 10. There you go. This is telling me 41.987, but the question says to the nearest degree. So t is approximately, look, that's almost 42 degrees. 42 degrees. Okay, when you're finding angles, remember that your units are always going to be degrees. Pop those in there. All right, and it's the same deal for all of these. You're not given the triangle. You are at this point in your working. So you are right at the point where you're going to do inverse. So theta is inverse sine of 0.8613. You put that in your calculator and you get whatever it is that you get. I don't think you need me to go through that bit. And the same for cos here. So theta is cos inverse of 31 over 53. I believe this is exercise 9G, finding angles. Correct me if I'm wrong, but if you need to practice those, exercise 9G. I hope that was helpful. Have a great rest of whatever part of the day you're in.